Alright everybody, so first thing you need to do is work on your opener, and if you look at the very first question, it says that you can actually use your graphing calculator in order to solve this. So if you go ahead and bring up your graphing calculator and you press the y equals button, okay, so the y equals button in the upper left hand corner, you can type in your two equations that they give you, so the 2x minus 15 and then the 4x plus 20. Now once you have this, you can go ahead and hit graph in the upper right hand corner, but you should notice that you cannot see where they intersect. So you're going to need to press zoom and then number 3 to zoom out and then hit enter. When you zoom out, you're almost able to see it, but you're not quite there yet, so you'll have to do it one more time. Press zoom, 3, enter, and get to zoom out one more time. Now you can clearly see that the two lines are intersecting, and we can go ahead and use our graphing calculator. Press second, trace, 5, enter, enter, enter. That then gives us the point of intersection at negative 17.5 comma negative 50. So that would be our answer for the first question in the opener. So going here, we should again have that negative 17.5 comma 50. Negative 17.5 comma 50. Okay. Explain why the system of equations shown below does not have a solution and what you would see on the calculator if you graphed it. So if you do graph that, you're more than welcome to. I want you to tell me what you would see. Otherwise, we should notice that they both have the exact same slope. So they have the same slope here, which means that these lines, if they would be graphed, would be side by side like this. These are parallel, so they will never touch. So they're never going to touch. They are parallel lines. Okay. Number 3, explain how you know the system of equations shown below has an infinite amount of solutions and what you would see on the calculator if you graphed it. So again, if you went ahead and graphed this, you'd be able to graph that bottom one on your graphing calculator, no problem. However, you would need to do something first in order to graph the top one. I would have to divide everything by 3 to get that y by itself. And when you do that, those 3's would cancel out, and I'd have y is equal to 18 divided by 3 is 6, and 24 divided by 3 is 8. Now that we have this revised equation, now we should be able to see that this equation and this equation are the exact same thing. So it's the same equation. So because it's the same equation, those lines are gonna, if we would have my purple line, and then let's say I have a red line, they would literally lay right on top of each other. It doesn't even look like I have two lines because they are the exact same thing. So if we would have graphed this, it would have looked like the same line. So same equation means same line. Okay. Moving on to number 4. Number 4 says, determine the order if the ordered pair 3, negative 5 is the solution to the system of equations shown below. So you can, since they just gave you the values of 3 and negative 5, we're just going to plug those in and see whether or not it gives us the same thing on both sides. Now, in order for it to actually be a solution to the system of equations, it has to work for both. So if I plug in 3 in for x, 2 times 3, plus 3 and plug in negative 5 in for y, that should equal negative 9. So 2 times 3, that gives me 6. Plus 3 times negative 5 gives me negative 15, so I have 6 plus negative 15. And if I combine those two, 6 plus negative, or just minus 15, should give me negative 9, and that is equal to negative 9. That one works. That's great, but that doesn't mean that it is the solution. I still have to check the other equation. So then the other equation, I have 6, and instead of x, I'm plugging in 3 again, minus 2, and instead of y, I'm plugging in negative 5, and it should equal 8. 6 times 3 is 18, minus 2 times negative 5 would give me negative 10, so minus and negative actually turns into a plus 10, and equal to 8. 18 plus 10 is 28. Is that equal to 8? You should definitely be saying no. So that means that this is not a solution. Okay, so the ordered pair 3, negative 5 is not a solution. Number 5 says, write a system of equations to represent the scenario shown below. Joey is selling adult and student tickets for the upcoming basketball game. Adult tickets cost $5 and student tickets cost $2. He sells a total of 125 tickets for a total of $550. Let X represent the number of adult tickets and Y represent the number of student tickets. So they already defined your variables for you. So first thing I would do is just talk about the total number of tickets sold. We have X being adult tickets plus Y being the student tickets. So total, he sold 125. That's going to be like my first equation that I would start off with. So one unit is just the number of tickets. The other unit that they deal with is money, and we want to keep the money with the money. So I know that the other thing that I'm going to have, and if you want, you can always put the little dollar sign. So I got 550. It's got to equal $550. Well, they tell us that an adult ticket is $5. So I got a $5 per adult ticket. Plus I have $2 for every student ticket. And there you go. They're not asking you to solve it or anything. It's just writing the equations. That's all we're doing here. Okay. So there is your opener. That's completely done. Hold on to it. I want you to turn everything all together. So you're going to be turning in your opener, your homework that was due today, and your exit ticket by the end of the period. Okay. So if you didn't already get your core, please make sure that you go get it, and then I'll get started. So the core, solving systems of equations. So if both equations are in your slope-intercept form, your y equals mx plus b, okay, then we can go ahead and use a graphing calculator and find that intersection. So we want to have slope-intercept and find the intersection. If both equations are in standard form, then we want to use the elimination method, which again we'll get back into. If you don't remember it, that's okay. If one of the equations has a variable already isolated or by itself, then use the substitution method. So two methods that we're talking about already, elimination and substitution. If the problem is a multiple choice, okay, and that's going to be pretty much all of your keystones. If it's multiple choice, then we can just substitute. We can substitute the answers into both equations and determine which one works. That's kind of what we just did on the last problem for your opener, number 5. It was just substituting in. If the lines have the same slope, then there is how many solutions? No solutions. Okay. But if the lines have the same equation, then there is an infinite number of solutions. There are infinite solutions when they have the same equation. So again, that's just that overlapping lines are the exact same. Okay. So this first one, a system of equations is shown below. What is the solution to the system of equations? Again, you should be able to plug these numbers directly into the problem, okay, since it is multiple choice. So go ahead and give that a try. I want you to plug it in and see if you can get it. So go ahead and pause the video right now and give yourself like a minute or two, see if you can get the correct answer. Okay. Hopefully you actually tried it instead of just continue watching the video. But you should have ended up with C. Okay, if I plug in 2 in for X and 3 in for Y, 2 times 2 would give me 4. And then plus 2 times 3 would give me 6. That's equal to 10. That one works. Then in the bottom one, 5 times 2 is 10. Minus 2 times 3, which is 6. Equals 4, and that one is also true. So both of them work if I plug in 2, 3. Okay. Number 2, Juan answered all 50 questions on a test. He earned 3 points for each question he answered correctly. He lost a point for each question that he answered incorrectly. His final test score was 102 points. The system of equations below describes the relationship between the number of questions that he answered correctly, X, and the number of questions that he answered incorrectly, Y. Okay. So part of the solution of the systems of equations is X is equal to 38. What does the value represent? So you're not actually asked to solve anything here. You're just asked, what is that X equals some number? It doesn't even matter that it's 38. What does it mean? Okay, so you got, does that 38 mean that the number of questions Juan answered correctly? Does it mean the number of questions that Juan answered incorrectly? Is it the number of points that Juan lost from questions that he answered incorrectly? Or is it the number of points that he earned from questions that he answered correctly? So basically what you need to focus on is in the actual question it says that it talks about X right here. And it says it's the number of questions that he answered correctly. So it literally just handed you the answer. All you had to do is read, and that's most of the questions that are on the Keystone. So it's just A. It's just the number of questions that he answered correctly. Number 3, this one's very familiar, hopefully, because we just had this one yesterday during the Derby questions. So again, we're looking at how many minutes did Anna spend running? Okay, so I won't read the problem over again. I read it yesterday. So what I would do, and I think it's the easiest way to do it, is try out these numbers and plug them in. So if I say I'm going to start with A, if I plug in 10 in for X, I would start with the one that's an easier equation. So if I plug in 10 plus what would get me 60? Hopefully you're able to say, well, 10 plus 50 is equal to 60. And then I'm going to plug in 10 and 50 into both the X and Y into the other one. So 15 times 10, well, that's 150, plus 10 times 50, that's 500. Is 500 plus 150 equal to 700? No, it's equal to 650. So this isn't it, right? So we need to try out the next one. So the next number that they give us is 20. So we try out 20. 20 plus 40 equals 60. So then 15 times 20, that's 300. Plus 10 times 40, well, that's 400. And 300 plus 400, does it give us 700? Yeah, it does. So then I know that my answer has to be B. It has to be 20. Okay. Next one, at an archery competition, archers get 7 points for each arrow that lands in the bullseye and 4 points for each arrow that lands in the ring surrounding the bullseye. No points are awarded for arrows that miss both of these areas. So if I'm given the system of equations x plus y is equal to 41 and 4x plus 7y equals 206, what does the y variable represent in Kelly's system of linear equations? So we're looking for, what does the y represent? So what we want to call the variable y is the number of arrows that land in the bullseye. So we're going to call this the number of arrows that land in the bullseye. Okay. So then the second question then is, how many points did Kelly score during the competition for her arrows that landed in the ring surrounding the bullseye? So using the system of equations that we're given, that x plus y is equal to 41 and the 4x plus 7y equals 206, okay, I can use that then to be able to figure out how many points she's going to get. So if I would take the equations that are given, because they're both in standard form, I want to try and get them to be able to cancel out. Now, in order to be able to do that, I'm going to need to multiply the top equation by something, so that way they can add together and cancel these out. Now, I'm going to go ahead and cancel out the x's. I think that's the easiest just because it's a smaller number. So I'm going to multiply this whole row by -4. Okay. So when I multiply this whole row by -4, that's going to then give me, and if it's okay with everybody else, I'm just going to rewrite this one on the top now. So I got 4x plus 7y equals 206. And then my new one, I'll write down here now. So when I distribute that -4 into everything, I'm going to get -4x, then minus 4x, or sorry, 4y, and it's going to be equal to -164. So now that I'm at this step now, I can go ahead and combine these two equations. I'm just going to add them together. Now, the trick here is, because this is elimination, I want to be able to eliminate a variable. In this case, I chose the x's. So these x's, when I add them together, they're going to cancel. So then I have my 7 minus 4, so I have 3y, and then that's going to be equal to 206 minus 164, which is 42. Okay. Then I just need to go ahead and divide both sides by 3, and I'll get y is equal to 14. That's only part of my answer. Okay. So the y is equal to 14, and I need to find the x value. So now I got to plug this 14 back into either one of the equations, and I would highly recommend that we start using this original x plus y equals 41. It's going to be just the easiest way to be able to get the answer. So if I plug my y value back into that equation, I'll have x plus 14 equals 41. And then I just need to subtract the 14, and I'll get x is equal to 27. Okay. So I have my x and I have my y. So since I had said that the variable y is going to be the number of arrows that land in the bullseye, then x is going to be the number of arrows that landed around the bullseye, so not actually hitting the bullseye. So those 27 arrows, I still need to multiply times the point value that I get for each of those. And if you look, okay, if you read back in the original, it says you get 4 points for each arrow that lands in the ring surrounding. So I have this 27 I still have to multiply that times 4. When I do that, I'll get 108, which is my answer of 108 points. Then the second archer, Deshaun, he had 12 arrows that landed in either the bullseye or the ring surrounding the bullseye. He scored a total of 72 points. We want to write another system of 2 linear equations to represent his performance. We're going to have x and y have the same representation as they did in Kelly's system in part A. So that means that x is going to be the one surrounding, and y is going to be the number that hit the bullseye. Okay. So the first equation, again, total number of arrows that were hit. Okay, regardless of where they hit, I got x and I got y. They're added together, and he hit 12 arrows total. That's an easy equation that you should be able to get no problem. And again, we're using the exact same points system as what Kelly was using in the previous question. So I should get a total of 4 points for every surrounding hit, and I should get 7 points for every bullseye. And they already told us that he's going to score exactly 72 points. So there's the 2 equations. And that's all they're asking for here. Then letter D, okay, it says a third archer, Lou, wrote a system of linear equations to represent his performance of scoring a total of 100 points. He solved the system of linear equations and found that the solution was 6, 8. Explain how you know that Lou made a mistake in solving his system of equations. So he created a system of equations that we did. Okay, so in his solution, we need to plug in the 6 and the 8 into our equations. Okay, so if I plug in, even though it wasn't necessarily for, we can even just use the generic point system of 4 and 7. If I plug in 6 and 8 for x and y in the 4x plus 7y equals 72, or sorry, 100, because this is the 100 points. Sorry. So I have 4 times the 6 plus 7 times the 8 is supposed to equal 100. 4 times 6, that's going to give us 24. And 7 times 8 is going to give us 56. So this is going to turn into 24 plus 56 equals 100. I think we should be able to clearly see, though, that 24 plus 56 is not 100. It's only 80. And 80 does not equal 100. So I'm fine with just having that as my explanation, right? 80 does not equal 100. So we're good there. Next, moving on. John spends $94 to buy packages of cleaning supplies for a camp. He buys T packages of towels. Each package is $6 and contains 8 towels. He also buys S packages of soap. Each package is $4 and contains 10 bars of soap. John buys 20 packages of cleaning supplies all together. So that's total number of packages that he bought. Write a system of equations to represent the packages of cleaning supplies that John buys. So first things first, we need to come up with that system of equations. Now, again, I like to start with the total. And if you read through, okay, it says, again, he bought 20 packages all together. So we know that the first equation, it should be equal to 20. Okay? And the only types of packages that there are either the packages of towels or the packages of soap, T and S. So I have T plus S is equal to 20. That's one equation. Then I have to talk about the other equation, which, again, keeping units together, now I'm not dealing with the packages, I'm dealing with the money. I need to know that my second equation is going to be equal to $94. That's how much he spent. Okay. We know that each package of towels is $6. I don't really care about how many towels come in the package. We're not really asked that or anything about it yet. So I need to know that it's $6 per pack of towels plus, and again, if you want to put units, it helps some people. Plus, then I have $4 for every pack of soap. And then those are my two equations. I got this equation, and I got this equation. Again, keeping the units together is going to be key here. So I have the units for packages, and then I have the units for the money. Okay. Then it says in part B, how many packages of towels does John buy? So we actually need to figure out how many packages he needs to buy out of the total. So again, because both of these are set up for standard form, I want to probably use elimination here. And again, I think it's going to be easier to cancel out the 4's, but that's just me. Some people would rather cancel out the t's. Some people are just more comfortable canceling out the first variable. Either way is fine. We'll still get the exact same answer. I'll just go ahead and cancel out the first variable. We'll keep it consistent. So in order to be able to cancel out the 6's, right, we want to cancel out the t's, then I need the t plus s equal 20. I'm going to need to multiply that entire thing by -6. So rewriting the first one, I had 6t plus 4s is equal to 94. Okay. Then the second equation, again, I have to multiply this one right here. I have to multiply that by -6. So basically, t times -6, it's just going to be -6t. Then I have minus now, because now it's -6 times s. It's going to be -6s. And then it's going to be equal to 20 times -6, which will be -120. Okay. Now we can go ahead, again, we're going to add these two together. The t's are going to cancel. So I'll have 4s minus 6x s. So I'll have -2s is equal to 94 minus 120. It's going to leave me with -26. I still need to actually solve for s, so I'm going to divide both of these by -2, and I'll get s is equal to positive 13. So that tells me that's 13 packs of soap. Okay, so that's soap. But that's not what they asked for. They asked for the towels, which means I need to then plug this back in and figure out how many packs of towels. Now again, using the original equation is probably going to be easiest here, using this t plus s is equal to 20. So I'm going to plug it back into that one. So t plus s equals 20. Well, s is now 13. So t plus 13 is equal to 20. If you need to, subtract 13 to both sides, and you get t is equal to 7. That's my answer. He's going to buy 7 packs of towels, and we should probably put that. Packs of towels. Okay. Then the last one here. Explain why it would not be possible for John to buy 16 bars of soap. Okay, so you have, if he wanted to buy exactly 16 bars, okay, you have to look back at the original problem when it talks about what's in each package. So if we go back up to the original where it talks about what's in the soap package. So package of soap, each is $4 and contains 10 bars. So if each pack contains 10 bars, is he able to buy exactly 16? Assuming we can't buy any parts of a package, you have to buy just 1 package, 2 package, 3 package. You should be able to say no, hopefully, because if I want 16, then that means I'm going to have to buy at least 2 packages. So at least 2 packages, and that's going to mean that I'll have 20 bars, not 16. So if you wanted to have exactly 16 bars, then you would have to buy them individually. You can only buy 1 pack to get 10, so 16 is not a multiple of 10. Okay. Next, I got your homework check here, so we'll do the homework check. So pull that out. If you need to pause, go ahead. And here is the answers. Okay. Again, if you have any questions on these, I know I'm not here, but if you want to star some of these problems or circle some of these problems that you are having an issue with and you'd like me to be able to go over tomorrow when I get back, that's perfectly fine. Just make a note of it. Something else that I've been seeing a lot of, and you may even see your no-name papers that are hung up on the board, please make sure that you're putting your names on these papers, because I'm having a lot of people not putting their names on them, and then you're not getting credit for your work. So please make sure that your name is on this paper before you turn it in. Okay. If you need to pause this to be able to check out the answers, go for it. I'm going to go ahead and end it here. So the next thing that you need to be doing is, after this video concludes, you need to open up the quizzes that has the Derby Day questions. You will not be able to see whether or not you got the right answer. You will not be able to review the questions or anything like that. So please make sure that you are using your name to be able to complete the quizzes, so that way I can get an accurate percentage. Okay. Alright everybody, thanks for watching, and I'll see you tomorrow.